In this video, we're going to take what we've learned about enthalpy and about our enthalpy reactions and combine them into something new using something called Hess's Law. For this, let's say we have an equation represented here by this A plus B, which is yielding the letter C. If we have that reaction, notice that we have 100 joules of thermal energy or heat. If we have another reaction that is C plus D, which yields E, we get 200 joules for our enthalpy. So then let's say we have a third reaction. We can say A plus B plus D will yield E. So how did I get that? In order to get that, notice that these top two reactions, you have C in two different places. You have it on the product side and on the reactant side, so it can cancel out. That's where you get the A plus B plus D, which can yield E. And Hess's law tells us that if we can simplify reactions in this way, then our enthalpies can also combine in a similar way. So in this case, we're adding that 100 plus 200 joules, so our enthalpy change is 300 joules. So let's look at this a little bit differently. There's a couple of things that you can apply with Hess's law. So in this first example, we still have that A plus B yielding C that is 100 joules of heat or thermal energy. Notice here, if we multiply everything out by 2, where we get 2A plus 2B plus 2C, or equals 2C, you will do the same thing to the enthalpy. That 100 joules multiplied by 2 is just 200 joules. Now let's think if we had half of all of those things. If we had half of that A for a reactant, half of the amount of B for a reactant, and we're yielding half of the amount of C as our product, we take that enthalpy of 100 and just divide it by 2. So we get 50 joules. And then the last thing to keep in mind, if you reverse that reaction, so notice at the beginning you had a kind of combination reaction. You were taking A plus B to get C. If instead you broke it down to a decomposition reaction, we get C breaks down to form A plus B. We just reverse the sign on the enthalpy, so it becomes negative 100 joules. Still the same amount of heat or thermal energy, but instead of adding in that thermal energy, you're releasing it in this case. So let's see what this looks like. Let's say we have these two equations, 2A plus 2B yields 2C, and it gives us 300 joules for our enthalpy. And then we also have E, which decomposes to form C plus D, and that gives off 400 joules. So we want to get this equation that's here in the red. So A plus B plus D yields E, and we want to know what that enthalpy change would be. So the first thing I would do, if I knew that I wanted A plus B in the final product, and I had 2A plus 2B for our options, I can just go through and divide those by 2. So if I take that 2A plus 2B yields 2C, divide all of that by 2, I get this equation right here on the right. So A plus B yields C. Because I divided everything by 2, I divide that enthalpy by 2, and it's 150 joules. We're not fully there yet. Notice in our final product, we want E to be on the product side, but here it's on the reactant side. So I'm going to do that rule we just learned, and I'm going to flip that around and reverse that reaction. So instead of E yielding C plus D, I'm going to get C plus D yields E. Because I reversed it, I flipped the sign on our enthalpy. So instead of negative 400 joules, it becomes positive 400 joules. So notice what we can do now. We can go through and once again eliminate that C. It's on the product side at the top, the reactants at the bottom. And now when we add that together, we get A plus B plus D, which yields E. That is exactly what we had in our first equation that we were hoping for. So now we can just combine those enthalpies. So 150 joules plus 400 joules will tell us that our enthalpy change is 550 joules. Remember that enthalpy right there is positive, which means this is an endothermic reaction. We have to add energy into that system, add that thermal energy. Let's look at another one dealing with actual chemicals. So for this one, we have 2 waters, which decomposes to form 2 of hydrogen gas and 1 of oxygen gas. We also have 2 of this hydrofluoric acid, which breaks down to form hydrogen gas and fluorine gas. Off to the side, we have our enthalpies written out, 572 joules and 542 joules. So what we want to solve for is having 2F2 plus 2 of the waters will give us 4 hydrofluoric acid and 1 of the oxygen. And we want to know what that enthalpy change would be. So similar to what I did last time, I'm just going to start working with things that I already know. So for example, I know that I'm pretty happy with having 2H2O, just like it has up here, which gives me oxygen right here and oxygen there. So I'm happy with the way that that is set up. So I'm just going to rewrite that first equation out to the right side, and I don't have to change the enthalpy because we didn't change that reaction at all. So it's still 572 joules. For this second one, notice that I need to flip it around because instead of having F2 in the products, I now have it in the reactants. And instead of having that hydrofluoric acid in the reactants, I now have it in the products. So I'm going to flip that around. Something else I notice, I not only need to flip it, but I also need to double everything because I went from 1 fluorine gas to 2, and I went from 2 hydrofluoric acid to 4 hydrofluoric acid. So flip it around, do it times 2. If you need to take that in 2 steps, if that's easier, you're more than welcome to do so. And this is what I should get. This 2F2 plus 2H2 should yield 4HF. When I flip around my enthalpy and I double it, I should get negative 1084 joules. Now, just like I did before, there's something that I can cancel out here. Notice on the products up here, we have 2 of H2. On the reactants, we have 2 of H2. We don't need those in our final product, and they cancel out anyways. So I write out that equation down below. It's exactly what it asked me to solve for, so we are happy with that. And then I just add them up. 572 joules for that first enthalpy minus 1084 joules will give me a negative 512 joules. So notice this is a negative enthalpy. We are going to be releasing that energy. It is exothermic. That energy is exiting the system. So I'm going to zoom out so you can see all of this. If you need to take a little bit more notes, go ahead and pause the video. Make sure your notes are up to date and that you understand this before you solve some examples of your own using Hess's Law.